Friends, my name is Abhinav Somvanshi and I am an MTech student studying in Nirma University, Ahmedabad. Today I am going to solve some gate questions about Master's Theorem, extended Master's Theorem. So firstly, you can see if a recurrence relation is in the form of Tn equal to a t n by b plus theta n power k log p n, where a is more than equals to 1, b is more than 1, k is more than equals to 0 and p is a real number, then at that recurrence relation we can apply extended Master's theorem. Extended Master's theorem is different than we have studied in Theorem. Okay, so this is extended Master's theorem. You can write it. So guys, let's see an example. Tn equal to t n by 3 plus n. Now we will compare this recurrence relation with the form. Okay, so by comparing we can say that a is equals to 1, b is equals to 3 and k is equals to 1 and log power p n is equals to 1. So by comparing this we can say that p is equals to 0. Okay, so now we will be going to compare a and b power k. Where a is equals to 1 and b is equals to 3, so b power k is more than a, so b power k is more than k. ठीक है ना? So we will going to apply this one. Okay, now we will going to see the value of p. P is equals to 0, so we will apply this one. Okay, so Tn equal to theta n power k log power p n. Now we will going to put value of k, p. Okay, so Tn equal to theta log, so we can get theta of n. So Tn is equals to theta of n. Let's see another example. Tn equal to 8 t n by 4 plus root n. Okay, so again by comparing this equation with the form we get a is equals to 8, b is equals to 4 and here root n. So root n, we can write root n is made n power 1 by 2. Okay, can be written as. Okay, so by this we can say that k is equals to 1 by 2 and again p is equals to 0. So now we will going to compare a and b power k. Okay, so 4 power 1 by 2, ठीक है, equal to So 4 power 1 by 2 is less than a. So we will going to see this equation. Okay, so Tn equal to theta of n power log b a. Now put values of b and a. We get theta is equals to Tn is equals to log four 8. Okay, this is our value. Now we will going to solve another example. Tn equal to 4 t n by 2 plus n by log n. Okay, now again we will compare this equation with the form. So we come to know that a is equals to 4, b is equals to 2, k is equals to 1, and this one here n is divided by log n, which we can be written as log n power minus 1. Okay, so comparing this, we can say that p is equals to minus 1. Okay, so now we will going to compare. Okay, a and b power k, 4 and b power k is 2. So a is more than b power k. So we will going to do this one. Okay, here so we have Tn equal to theta of n log b a. Now put value of a and b. Theta is equals to n log 2 4. So we get theta of n square. So guys, let's see another example. Tn equal to 1 by 2 t n by 2 plus 4 n square. Now again compare this equation with this. Okay, so we get a is equals to 1 by 2 comma b is equals to 2. Okay, see guys, a is 1 by 2, but for applying Master's theorem we have to get the value of a should be more than or equals to 1, but here value is less than 1. So Master's theorem can't be applied on this. Okay, this is limitation of extended Master's theorem or Master's theorem. Okay, let's see another example. Tn equal to 2t n square plus 4n. Now again guys, we will compare this equation with the form. Okay, so we get a is equals to 2, b is equals to 1. Guys, again b is equals to 1. For applying extended Master theorem, the value of b should be greater than 1, but here in this equation the value of b is equal to 1. So again Master's theorem can't be applied on this recurrence relation. Okay, okay guys, see another example. Tn equal to 2t n by 2 plus n divided by log n. Okay, so again we will compare this equation with the form. So we get a is equals to 2, b is equals to 2, k is equals to 1, and again this n divided by log n. The power of log n should be minus 1. So we can say that p is equals to minus 1. Okay. Now compare a and b power k. So we get a is equals to b power k. So in this we will going to see in this, and we get value of p is minus 1. So this one we apply this one. Okay, so Tn equal to theta of n power log b a log n. So now put value of a b. Okay, theta is equal to n log 2 log n. So we get theta is equals theta n log n. So guys, let's see another example. Tn equal to 4t n by 2 plus n divided by log n whole power 2. Now again guys, we compare this recurrence relation with the form. So a is equals to 4, b is equals to 2, and now see this. So by comparing with this, we can say that k is equals to 2 and p is equals to minus 2. Okay, why we write p is equals to minus 2? Because n is divided by log n. Okay, so power of log n should be minus 1 and whole power is 2, so minus 2. Okay, that's why we write p is equals to minus 2. Okay, now compare a and b power k. We get a is equals to b power k. So in this, okay, now we will see value of p. Now we will compare value of p. P is minus 2. So we will go and see this one. No, this one. Okay, C1. So Tn equal to theta of n log b a. Now we will going to put value of a and b. So theta is equals to n log 2 4. So this one again theta of n square. Let's see another example. T equal to 16 t n by 2 plus n power 4. Okay, now again compare this with this form. Okay, again a is equals to 16, b is equals to 2 and k is equals to 4 and p is equals to 0. Okay, now we compare a and b power k. So 16 and b power k is 2 power 4. So a and b power k is equal. So we will see under this one. Okay, this one. So now value of p is equals to 0. So p is equals to 0. So we will consider this one. Okay, this one. So Tn equal to theta n power log b a log p plus 1 n. Okay, now we will put value of a, b and p. Okay? So value of a, b and p in the equation, we get Tn equal to theta n log 16 2 log 0 plus 1 n. So we get theta n power 4 log n. Let's see another example. Tn equal to 6t n by 3 plus n log n whole power square. Okay, so now we will going to compare again this equation with the form. So we get a is equals to 6, b is equals to 3, k is equals to 2 and p is equals to 2. Okay, now we will compare a and b power k. So b power k is 9 and a is 6. So p power k is more than a. So in this we will see in this. Okay, so now we will check value of p. P is equals to 2. So again this one. Okay, so Tn equal to theta n power k log p n. Okay, now put value of k and p. So theta is equals to n square log square n. Okay. So guys, let's see another example. This example is somewhat special. Okay, let's compare this recurrence relation with the form. Okay, we come to know that now we get Tn equal to t 2n minus 4n square divided by 2. Okay, what I did is I taken this to that side, okay, and divide by 2 both sides. Okay, so we get this equation. Okay, so we can see that okay, I just multiplied 1 by 2 both sides, this one and this one. Okay, I get, I can write 1 by 2 t 2n minus 1 by 2 into 4n square. Okay, again we can write 1 by 2 t 2n minus 2n square is equals to Tn. But now if we can compare this equation with the above form, okay, we come to know that there is no negative sign in the form, but we have here. Okay, so this equation cannot be converted into the form of Master's theorem applicable form, but we can convert it. See how we can convert it. So see guys, now let 2n equal to m. Okay, now put value of m in the above equation what we have initial. Okay, t m equal to 2 t m by 2 plus 4 m square. But see guys, I have written it wrong. Okay, so we have to change it. It should be m square. Okay, so now see, compare this equation with the form. Okay, we get a is equals to 2, b is equals to 2, k is equals to 2, and p is equals to 0. Okay, and we have everything. A is more than equals to 1. Okay, this one is okay. B is more than 1. We have b is equals to 2, so this one is also okay. K is more than equals to 0. We have k is equals to 2, this one is also okay, and p is equals to 0, this one is also okay. So okay, so we have converted the equation which was given initially, on which we cannot apply Master's theorem. Now converting it into different recurrence relation, now we can apply. Okay, so now we compare a and b power k. Okay, we get b power k is more than a. Okay, because 4 is more than 2. Okay, so in this we will see in this. Okay, now we will see value of p. Value of p is 0. So in this one, okay, so we get t of m equal to theta m power k log power p m. Now put value of k and p. We get theta of m square log power 0 m. Okay, so we get theta is equals to m square now. Okay, so now we get theta is equals to m square. Okay, theta of m square is equals to tm. Okay, now put value of m in the form of n. We get t 2n equal to theta of 2n square. Okay, we get theta is equal theta of 4n square. Okay, you have seen how we converted a recurrence relation into the form on which we can apply Master's theorem on it. Okay, so if we have any recurrence relation which can't be in the form of this one, but by applying some algebraic equations we can convert it into the form of Master's theorem applicable form. Okay, so we have seen many examples. Now I will tell you we can apply only Master's theorem only on the form which has b more than 1. What does it means? It means if we have a big problem, so b, if a value of b is greater than 1, it means that we going to divide the main problem into sub problems at every step. This is given by the value of b. Okay, so it has to be greater than 1. Okay, we have to divide the problem. That's why mainly the problems of divide and conquer can be solved by Master's theorem generally. Okay, but there are some problems which can be solved by Master's theorem which is not of which is not of divide and conquer. Okay, so if a problem you get on recurrence relations in GATE, so find out its form. Okay, and if it is a form of Master's theorem, apply Master's theorem. So don't use recursion tree method. It will take your time, okay, to solve, but applying Master's theorem you can do that question in few minutes, okay, but you have to also know substitution method. Okay, if you didn't get a recurrence relation which is in the form of this form, okay, so what you will do, you will apply substitution method. It is the best method to solve, okay, only on the problem which is not in the form of this. Okay, so always use substitution method, okay, if you can't convert it into the Master's theorem form. Okay, 3. Thank you guys for watching my video. If you have any query, please comment and please subscribe my channel. I will post new videos every week. Okay, thank you guys.